I am Khemlal Janghel, Assistant Professor of Department of Mining Engineering in Rungta College of Engineering and Technology R1 in Bhilai. I began my career after passing out from IIT ISM Dhanbad in 1979, and after that I joined Tata Steel Mines Division in Novamundi Iron Mines as assistant manager in the same year. After that I completed my 25 years of service in Tata Steel and I reached to the level of head operation. After that, in 2005 I left Tata Steel and went to multinational companies in Nigeria, where again I was attached to mining industry, particularly with reference to iron ore mining. So, I was having that time 25 years of background from Tata Steel, and I soared up to the level of chief mining engineer in ACC's overseas project in 2008. I worked for 1 year there with ACC overseas project under the banner of Dangote Industries in Obajana cement plant of Nigeria. After I was there as deputy general manager, and then I came back to India in 2009. I joined Rungta Mines Limited in Barbil, where I was senior general manager for 6.5 years almost, and I retired from that company in the year of 2016 January. I joined as advisor technical. I joined as advisor in Adani Enterprises in Ambikapur project. I remained for 1 year. After that, I joined NIT Raipur for teaching. That was my first teaching experience, and I worked there as honorary faculty for 3.5 years, from 2018 to 2021. After that, I got retired from there at the age of 65, and I joined Rungta College of Engineering and Technology in the Department of Mining Engineering as assistant professor, and since then I am working there. So, with this introduction, I would like to start my deliberation on lecture number 3, drivage of incline, drift and adits in mining, which is the subject of, basically it is the all the three terms are used for accesses, different types of accesses in the mines, particularly for reaching the underground deposit. Drift, actually except the drift, if you see incline and adits, these are the accesses from the surface, from the superjacent ground, as per the terminology of DGMS mines. Superjacent means the ground which is exposed to sky or which is adjacent to the surface. So, that is the meaning of superjacent, and from there the accesses are made. Incline, as the name implies, incline means it is having inclination and heading towards the deposit in underground, starting from the surface. Similarly, adits are the horizontal access to the hidden deposit below the earth. Particularly, this horizontal access is made for the deposit which is hidden in upper part of the hill, and adits are made normally from the foot of the hill toward the deposit. Drift is an access which is made from underground shaft, and drift, particularly with reference to metal mining, it means it is running parallel to the strike. or along the strike of the ore body, and from there cross cuts are made to enter into the body. I will show in the diagram in the next slides. So, these are the things which I have already explained. Drift is, again we have to see that drift is the access from underground to underground, it is not from surface. Let us be very clear about this. Whereas, adits and inclines are the accesses made from surface, that is superadjacent ground, to underground mining portion where the deposits are lying. So, one thing is very common among all these three types of accesses, the cross sections are normally rectangular, though if we use the we will come to that how the this drift borers are used, we will see that part, but here I am just saying that all the three accesses are kept or given to the shape of the cross section in the form of rectangle. So, that is most important. So, here you can see this is the hilly hill top, and adit is made on the foot of the hill to the ore body, and this is horizontal axis, unlike to the incline. Incline is having inclination. Normally inclines are kept at the inclination of 1 in 2. 1 in 2 means that is the maximum side. Normally we have seen the walkable and easily walkable inclines are 1 by 4. I mean to say 1 by 4 is tan of 1 by 4, which is hardly around 8 degrees or so, 1 by 4, whereas 1 by 2 is corresponding to 26.5 degrees. So, 1 by 2 is tan of 0.5. So, the inclination theta can be given as inclination theta with respect to the horizontal line can be given as 26.5 corresponding to tan of 1 by 2. So, one is actually this gradients are expressed in two ways. One is in degree, another is in perpendicular drop by the horizontal distance covered. So, if it is perpendicular drop towards the verticality of the ground is 1 meter, by covering 2 meters of the horizontal length of the axis. So, it is forming tan 1 by 2, tan theta equals to 1 by 2, and that is theta is corresponding to 26.5. Similarly, for 1 by 4, which is the most common inclination, that is corresponding to around 9 degree or so. So, that way it is the incline, but adits are horizontal. Slightly it is kept slanting outward, that means slight inclination is given, very negligible inclination is given to the adit, because in old time the mechanization level was very low, and the people used to push the tub, empty tub towards the ore body from outside, that means it was upside pushing, and loaded tubs, because it was becoming difficult to push it. So, loaded tubs used to go down by its own gravity to the downward hill, I mean to say downward side of the adit. So, the inclination of adit was being kept 1 in 300, 1 in 400, very gentle inclination was being given. So, that was the that is the use of adit, and adit is very, I mean to say it is very shortest and most convenient accesses made to the ore body seated inside the top of the hill, as you can see in the diagram. If the adit is ending with the ore body at the mid of the hill, then it is adit, but when it is through and through, that means opening both the sides, one side is entry, another side is exit. So, in that case it is called tunnel. How the adit and shafts combination have been made here, This is one of the pictures, one of the diagrams showing the combination of adit and shaft. So, you can see that shaft verticality is there, and on the top the adit is also there. So, after adit it has converted to shaft, and the shaft is not opening on the surface of the hill, top surface of the hill, and it is accessing to the body, to the ore body at the bottom through different levels. So, the level which runs parallel to the strike of the ore body is called drift. Here, how the adits are used along with shaft combination can be seen with incline, with the different combinations of the beds. From crusher, on the left hand side the dumper is dumping into the crusher, and it is using the different conveyors to carry the crushed material to the bottom, and from there it is going to the underground shaft, and from shaft it is being pulled up on the top for processing, if the processing plant is beside the shaft, that on the headgear shown on the top. So, right hand side may be the processing plant, that is why it is after crushing it is going up for further processing. So, here is the typical combination of the shaft versus adit. This is a 3D diagram in which you can see at the middle, on the left hand side is the body, ore body, and right hand side is the vertical shaft, and in between there are spiral, there is a spiral kind of drivage made, which is called actually spiral ramp. It is called spiral ramp, and it has been opened from the bottom of the open cast mines. You can see on the top. Similarly, there are different levels developed from the shaft itself towards the body. So, those level is basically the working. The level is the working. It is basically a working which is spread over a particular level area, that is called a level. So, in this you will be finding there are so many levels, and in between that, in between two main levels, if it is the half level not connecting to the shaft, then this is called sub level, and that is used for stopping purpose. Here you can see the clear picture of the drift. On the right hand side block, if you see a small hole at the bottom, that is a passage coming inside the ore body, and that is parallel to the strike. So, that is called drift, and across that so many small drivages have been made to the chutes on the left hand side, where the above the chutes the blasted material of the stope is kept. So, that is drained out through the chutes, inbuilt chutes in the ore body itself, and that is draining the material, and it is coming to the wagon on the drift. The loader is bringing the material from the bottom of the chute to the drift, to the wagons kept on the drift, and from there the wagons are the tubs are pulled out. Tubs or wagons, whatever you say, wagons may be very big, but it is tub basically. So, the tubs are pulled out through that small hole shown in the right hand block, and from there it goes to the shaft on extreme right of the block. From there it is hoisted up. Here it is very clear picture of the drift. The blue lines are showing the accesses. The blue lines from the shaft top. The headgear is shown on the top. The hoisting drum shed is also there on the top right hand side on the surface, and the ore body is on the left, which is in brown color. Now, you will find that vertical shaft is having two main levels, one on the top, another at the bottom, and those two levels are connected with spiral ramp. In between, from the mid of the spiral ramp, there is a drivage made to the ore body, which is parallel to the strike of the ore body, but that is sub level, because it is not getting connected to, it is sub level, but you can say for the primary definition, yes, it is also a kind of drift, but the major drifts are on the top and at the bottom. So, these are the two drifts which are running parallel to the strike of the ore body from the shaft, and mid one is sub level, and the horizontal part which is parallel to the ore body strike of the ore body, there also you will find that that small portion is called the drift, which is originating from mid of the spiral ramp. So, this is the drift which is starting from underground and connecting to the ore body in parallel to the strike of the ore body. That is the fundamental thing. But in coal mining, you will see from the top of the diagram, you see that incline number 1 and incline number 2 are there on the left hand side and right hand side. So, these are underlined with red underlining part, and those are the inclines straightway coming down along the dip of the coal seam, and the drivages across that main dip, that is main dip incline. That dip incline is having the inclination of around 1 in 4, 1 in 2, 1 in 3, like that. So, that is starting from the top, it is a plan view of the coal seam. You can see the board and pillar development also made. At the bottommost part of the diagram, you will find drift. Now, how the drift is connecting? Here in coal mining, the drift has got a different meaning. Whatever I told about drift, the drivage running parallel to the strike of the ore body was with reference to metal mining. Here it is with reference to coal mining. So, and here also cross cut is also inclined cross cuts, which are not in parallel or along the main dip of the incline, coming straightway down along the dip of the ore body or dip of the coal seam. So, that is cross cut and straightway coming down, and that is there is a ribbed portion shown at the bottom, that is called drift. This is the drift. Actually, the coal seam which has been shown blue has been affected by the fault plane. You can see the inclined fault plane, a straight line, and suddenly there will be, when we come from the top seam working, suddenly along the fault plane you will find out that the coal seam is vanished. So, how to connect that? So, from there we will make a drivage again, which is much inclined than the coal seam inclination, or cutting across the fault plane and going to the down seam on the left side. So, the drift is used here for connecting one part of the seam to other part of the seam, which is running almost in parallel. So, that way drift is defined here in coal mining separately. It is differently, rather it is differently defined in coal mining with reference to coal mining. We will come to the ways of method of drivages now, how to make drivages. Obviously, the first part is drilling blasting. So, here it is the drilling jackhammer drilling, which is mounted on a pneumatic jack. Pneumatic jack means which is telescopic, and which the height of this can be changed according to need of the blast hole to be drilled on the mining face. Mining face is shown by vertical line, hashed line on the right hand side. So, and the pneumatic jack is getting anchored through its pointed knob at the bottom, so that it will not slide back once drilling on the face. Here you can see the people are working. So, the left hand view is the side view and right hand view is the section XX as shown on the left hand view, side view. So, left hand view, if you see on the extreme left, you will find the supports which have been kept there. On right hand there is a gap, that gap is around 7 to 10 meters kept away from the face, and that part you see that how it has been there is a vertical member of the scaffold along which vertically the scaffold can be shifted up and down depending upon the requirement of the workers to cover the working height. So, this way the drivages are made manually, and the muck is taken out and that is loaded onto the tubs and sent out. This is the horizontal holding of the drill and you can see that vertical member is having a handle knob, screwed handle knob. So, by virtue of which the whole horizontal member of the frame can be slided up and down. Similarly, it can be shifted also along the face to make the drilling on the face. This is jumbo drilling. This is tire mounted or even traction mounted, where the ground is most rugged one, so where tire life will be difficult to get properly, I mean to say, for its full longevity of the tires. So, there we go for choosing the crawler mounted. Crawler means it is a traction mounted, or have you seen, you must have seen the traction propelling system of the armored tanks, battle tanks. So, similarly the traction pads are there instead of tires. So, that can work, and the boom, the drilling boom can be, it is having hydraulic jacks, so that the drill machine mounted on the top can be brought down and pushed up, or even the laterally it can be also shifted as per the requirement of drill on the mining face. This is just a section shown. Coming to the blasting the hole, blast hole, see on the left hand side 1/3 is stemming, and on the right hand side the explosive is filled up. Explosive has to be covered from outside of the, where the mouth of the hole is there, the blast hole is there, because the explosive energy should not escape out while it is undergoing the blast. So, that escaping of the energy has to be confined within. So, stemming of the chips and materials are to be given. So, that after that the blasting is done, so that the rock inside is blasted properly. Here the different patterns are there of the blast holes. The topmost view is the front view, then next row is the plan view of the blast holes. You will find that extreme blast holes on the section are drilled outwardly, because that drilling is required outwardly, because it will take care of the lateral drilling. If some gap is there from the edge of the face to little inside while drilling, because machine has got its own width, so it cannot go to the extreme corner of the section. So, it will be drilled a little outwardly, so that it will take care of the drivages on side walls properly to make a smooth wall, and also at the floor to give a smooth floor, on the top smooth roof. So, this is required outward drilling, this is requiring outward drilling, that is called V shape pattern. Then similarly, the bottom pattern is called the fan shape, which is of the fan shape. The right hand side section is shown, side view, that is showing the fan shape. Similarly, at the bottom right hand side you will find the fan shape like that. Here also the sequence of blastings are there. The innermost is blasted first, so that free face is created. After that, next round the middle row is gone, then third round, after that third row is gone, and extreme last row, which is nearest to the roof and sides of the cross section of the drift or cross section of the drivage, is blasted, so that the free face goes on developing from the center. Free face under cutting by coal cutting machine. This was the machine being used for making free face from the bottom. This is just the plan view, and the side view is shown from the on the right hand side, the top view. You can see there is a cut at the bottom given by the coal cutting machine, but these are not used now very commonly these days. Maybe hardly 1 or 2 places it is being used, the remaining part of the machines, otherwise these have been outdated. This is the coal cutting machine's diagram. The front portion, if you can see, there is a jib, JIB. So, that was going inside the coal face to cut. It was only suitable for coal face, it was never used in metal mining because rocks are very hard. Then charge, what are the sequences of blasting? Charging the blast holes, then connecting them with detonating cord or electric wire connections, then electric with exploder, ignition has to be given with safety fuse, and blast it. Then wait for 5 minutes, then you go to the mining phase, check for the misfires, etc. If it is there, it has to be rehandled. and then we can give clearance to the mining phase. So, excavation and mucking is the loading and transportation is, this is the profile of the blasted material on the mining phase. This is the ideal profile, normally does not happen. The floor portion you will find the thinner layer of the material, blasted material is spreaded, which is raised up to give this section. This is the side view of the face, mining phase. So, to give this section of the blasted material, so that it is lifted properly with the bucket filling factor, highest bucket filling factor of the loader. So, this profile has to be there always. This is the exploder diagram with electronic circuit on right hand side. Now, excavation, loading and transportation, the rail track mounted, track chain mounted, tire mounted and conveyors. These are the types of means of transportations. So, the most common thing in underground mining is track haulage. Track haulage is hardly this is 600 mm width, and each tub is about 1 ton capacity, and these are hauled by locomotives of around 125 HP to 250 HP. Locomotives are there, even 430 HP locomotives are there. In metal mines, locomotives are not allowed in coal mines, because it is the exhaust chimney can give up the incandescent particles of the fire. So, it may cause fire, that is why it is not used in underground coal mining, but open cast minings very commonly the electric locomotives are used. Maybe some electric locomotives are from overhead line like our railway locomotives, and but some of the locomotives are diesel even in underground mining, of course in the metal mining only, not in coal mining. So, these are the tubs dimensions of 1 ton tubs. So, prime movers are diesel engine and electric motors only. The electric motors may be of two types, one is the DC motor, another is the AC motor, but normally AC motors are avoided to use, because even if AC supply is taken from the, like in railways or like in underground mining or even in open cast mining, the ACs are converted to DC, and then it is running the DC motors to cause the movement of the locomotive. Why? Because DC motors are having very easy control about braking, Ward-Leonard control or these kind of controls are very fast on DC supply. That is why it is used for safety purpose. Suitability of locomotive haulage, you can see 1 in 25 or even lesser gradient, best is 1 in 15, this is not more than that, and ventilation has to be very good. Similarly, the men and material movements are independent in this. This is the diagram showing mechanized scraper loading. You can see the scraper on the extreme right hand side bottom where it is touching the muck. The set of ropes, the wire ropes, steel wire ropes, one tied from the bottom, another tied from the top, and it is just like pulling one cord, another cord, bottom cord, top cord to suit the requirement of the grabbing the material from the bottom of the face and then sliding it to the ramp which is shown there on the left hand side. After that it goes to the tub by sliding up of the material by the scraper bucket. This is the rocker shovel which is loading from the front and putting and dumping the material on the back. If some tub is there on the back, you can see the raised portion of the bucket which is loading the material into the tub on the back. This is track mounted basically. This is the diagram of auger miner. It is cutting the softer rock and taking out the material, and through a conveyor belt as shown by dotted line, it is loading the material onto a tub or car on the left hand side kept. This is the gathering arm loader. Basically it is having this is called alpine miner because it is continuous miner, and its head is like that. Just see the picks which is made of tungsten carbide, and that is cutting into the mining phase of the drift or the cross cut of the drivages, and there is at the bottom there is a pan plate. There are two wheel type of, see the armed wheels, those wheels are skewed on one of the sides, only one side. So, when the material is falling, it is gathering the material and it is sending to the conveyor belt as shown on the back of that it is shown in the down position. While loading, it goes to the up position with the help of hydraulic jacks, and boom of the alpine miner can be adjusted according to the height of the drift or the drivages. This is tunnel borer machine. This is the fastest machine. This is boring, and at the bottom there is a material collecting pan at the bottom. That material is sent to the conveyor on the back, and it is conveying the material outward away from the tunnel borer, and this is very fast machine. You can say, sir, it is boring circular section. Yes, then how to make rectangular? It can be made rectangular, like it is made tunnel. Tunnel is passing through the, you must have seen tunnels passing through the hills, cutting across the hills, and the bottom portion is not the arc shape as cut by the borer. It is made horizontal, it is made leveled well, so that cars and other vehicles can move. This is armored face conveyor used on long ball face. This is the ribs shown are called the flights, which is holding the material to push ahead along with moving chain centrally tied with the flights. This is load haul dump. This machine is used in underground for low profile loading. So, it is mucking, it is digging into the material, blasted material, and loading by reversing and then forwarding, coming forward, and there is a low profile dumper. This is the dimensional feature of the load haul dump. This is the, you can see the photograph of a low profile dumper. On the right hand side there is a bucket, front is the cabin of the dumper, and on the back of the, I mean to say back side, the body which can swivel with the pivot with the main driving cabin part of the dumper, giving very shorter radius of curvature for turning. So, that is filled up by that load haul dump loading machine. So, you can see here the dumper body, the back side is the scoop body, and the left side shown is the cabin of the dumper, and how it is having smaller radius of curvature by swiveling mechanism, it has been shown in the plan. So, this is the low profile dumper. The height is hardly, you can say, maximum up to 3.2 meters, maximum going up to 4 meters, 4.2 meters. So, but this body of the dumper body has to have the lower height. You can see the bucket on the right hand side of the loader. So, that is scooping into the material, that is digging into the material, and it is taking out the material. After that, it is lifting the bucket and it is going back, moving forward at 90-degree angle from the mining from the direction of taking away the material from the mining phase, and then it is moving at 90-degree, kept on the dumper side by, and there it is loading by raising the bucket, it is loading the dumper. So, and that dumper, as you have seen the ramps in the cross sections in the previous slides, that is moving out on the ramps. The ramp's inclination has to be there, not exceeding 1 in 16. 1 in 16 in underground mining, that ramp inclination is allowed, not more than that. So, 1 in 16 means the ramp horizontal distance covered is 16 meters, then only it will have a level fall of 1 meter. So, that is called 1 in 16. So, those ramps are made with, there are two different ramps made, either one is for coming down of the empty dumpers, another for going up to the by the with the filled up dumpers, with the loaded dumpers. So, that ramps are made, two different ramps are made for connecting with two different levels, and but in case of the ramps is covered, it is covered between the two levels, the distance, the vertical distance is covered by the ramp. Mind it that its inclination should not be more than at any place should not be less than, more than 1 in 16, and the curvatures are also to be taken care, because in underground mining the lighting is not that proper like in open cast mining. So, the two different ramps are made, or else the ramps are made quite big one, I mean to say bigger section, giving a partition, a divider at the ramp divider or width divider at the middle. But normally middle divider is not kept, because it will cause the roof support problem on the wider axis of the ramp made. So, two different ramps are made, or else even if divider is given, that is extended up to the roof, so that it also gives the support to the roof. So, this is the overall dumping arrangement. In some of the mines, the conveyors are used, as I have shown the different types of conveyors. Like on long wall face, there will be a gate conveyor taking the material, receiving the material from the armored chain conveyor along the long wall face, and that will be put to the gate conveyor. That gate conveyor henceforth will take it up to the top of the mines on the surface for its washing through a main conveyor, and that conveyor is going along an incline. Obviously, the conveyor needs an incline to go up, and the inclination of the conveyors are kept below the angle of repose. Why? Because angle of repose, you must be knowing, angle of repose is that angle of the slope of the material which has fallen from the top and got stacked on the ground and got reposed naturally. Repose means stagnant, the further sliding of material does not take place after that. So, that is around 38 degree in most of the cases of the different materials. So, the conveyors are kept at the angles hardly up to 32 degrees, not more than that in any case. 32 degrees also very high. Normally, the most of the inclined conveyors, this rubber bed conveyors are kept at 28 degrees, not more than that. This is the cycle of the actually this is the cycle we are using for the first cycle is the phase preparation. The phase preparation means whatever blasting has taken place, we need a free phase without any loose material hanging, because that will cause the inefficient blasting. That may come if a boulder is hanging, that will come out just like boulder only once it is blasted. It will never be coming in fragmented way, whereas we need good fragmentation after blasting for better handling by the loader. Next operation is, you will find out that next operation is before blasting we have to remove the pumping etc., pumps etc., pump pipes and also the ventilation pipes, those are to be removed. Then we do blasting. Then we, after blasting, after 5 minutes we resume ventilation there. Then we do 5 minutes checking, 5 minutes waiting. After that we resume the ventilation pipe there, and then only we go there, because it is very dusty. Actually 5 minutes gap is given after blasting for two of the reasons. One reason is that the dust must go away or settle down, then only the workers can go to resume the work. And secondly, any misfire or any you must have seen the crackers after lighting its that cord on the outside cord, you will find that it has gone to the inside of that cracker body, but it does not burst. It takes 3 minutes 4 minutes time. So, similar kind of incident may take place in case of explosives also. So, that is why 5 minutes is given to explode, and after that going to the face. These are the two major reasons. After that we go to the face and we see any misfire is there, misfire is handled again to fire it and then make it clear that there is no explosive adhering to the mining phase. After that we resume the we bring the loaders etc., we load the material, take out, and the place which has been exposed by removing the muck, by mucking operation or digging and excavation operation and loading operation, that is not refilled with water. So, we have to bring the if it is watery seam or watery place. So, this is the cycle of the operation for drifting or the drivages of drift and adits and even inclines. Only in case of inclines we have to little bit careful that we have to drive keeping the constant inclination by having the survey work done very regularly with the help of surveyors. This is the ventilation pipe shown. there are two types of fans used. One is exhaust fan, as shown in this case. The air from the mining phase is getting sucked by the exhaust fan on the top surface and it is going out. This is the forcing fan. Forcing fan is kept at the bottom and it is hardly say 5 to 7 meters away from the tip of the pipe inside, and the pipe tip is the end of the pipe is 7 meters away from the mining phase, and it is forcing the air from pipe to mining phase, and that forcing air is going out from the other remaining cross section of the opening leading to the surface. So, thanks to all of you.